Okay, just going to do a real quick thing on number 8 from the electric field worksheet. So we have our three charges. I called them A, B, and C on this example. I think they're 1, 2, and 3 on the solutions. But if you look at it, the negative charge will create an electric field that points toward it. The two positive charges will create electric fields that point away from them and directly away from them. So what I am going to do is treat all three of those vectors separately. So I'm going to start with what I called E sub A, the negative 4 nanocoulombs. So it's going to point down and to the left because it's going to go toward that negative charge, because that's how electric charges work. So what I have here, let's see how well you can see that. Because it's 0.5 and 0.5 away, that gives me a 45-degree angle. I'm going to assume you guys can do that math. And then I found what the value was. I just did kq over r squared. The distance I found just using Pythagorean theorem is 0.707. So this times this. Nice thing, the 10 to the minus 9s cancel. So I got 72 newtons per coulomb. And then I looked at that and I said, oh, because it's down and to the left, both of those components are negative. I'm going to use cosine 45 and sine 45. Now, those two are the same, so I get negative 50.9 and negative 50.9 for the x and y components of vector A. So I'm going to save that. Then on the back here, I look at B. B is the one that was straight up, so it didn't require any components, and I just did the calculation for it, and that's 180 newtons per coulomb. It's the closest one. It should be the biggest. Sorry that it's deciding to focus back and forth here. So that's all y component. Then C is the one that I have to do a little bit of work, because this side of the triangle is 0.8 meters. This side is 0.5. So I use that to find the angle, and I get that to be 32 degrees. Just using inverse tangent. Find the overall value, and I get 30.3. It's the smallest charge and it's farthest away, so it makes sense that it's the smallest of the individual values. Then what I have to do is say, all right, it's pointing up and to the left, so the x component's negative, the y component's positive. Do cosine and sine, and I get negative 25.7 and positive 16.1. I take all of those together. I add up all the x's, I add up all the y's. Let it catch up on the camera there. And so I take the y's, we have the negative, oh, my finger's confusing it there. The negative, so that gives me a negative 76.7 in the x direction, because the two were to the left. And then in the y direction, we have the up and the down and the other up. That gives me 145.2. So, all together, I find, so I kind of sketched it out here, just scaling really poorly. This is about 76.7, and about double that is 145.2. So I look at that, E, and then to find the overall magnitude, I just use Pythagorean theorem. And then to find the angle, I just use those values there. I get 117.8 degrees. You can kind of mess around with how you do the angle. You could find this angle here, and you would get 62.2, and then I just kind of figured out from the positive x-axis, and you can do that. All right, well, good luck with those. That one was definitely the longest of all the problems, but it involved vector math that hopefully is vaguely familiar to you.